Okay, I set the class exercise of looking at some claims data and seeing how that data could be mapped onto some of the classic loss distributions. What I've got here is that spreadsheet with claim data, which you can find on Moodle, and these are the individual claim amounts. So 19.27 there, and we'll go down to the bottom of the distribution, and we can see there are 1,804 pieces of data. Just to get a sense of roughly the ballpark they're in, I've calculated these values here. So that's the minimum value of data, so almost zero, suggesting perhaps we're going to be looking at an exponential or a Pareto sort of distribution. There's a lot of very low values. The maximum is 117,000, so some quite high values. The average is 429 or 430. Standard deviation is 1807. So what I want to do first of all is to group this into a histogram. So I've set up a start value of 0, which is just below the lowest value, and a step value of 10. And then you can see here start value, F7 plus step value, and so on down there. So we've got the groupings we're going to group our data into as a histogram. And I've written some Visual Basic behind this button here, which will go through this data and group it into the histogram. So if I click the group data button, I can see my Visual Basic coming up here. I've got for A equals 1 to 14,804. Obviously I could do it slightly more sophisticated by doing a do loop until you reach the blank data, but just to keep it very simple to illustrate the point. And value equals cell A, 1. So value equals 19.27 there, that's that value there, that's good. Index 1 is going to work out which group that value goes into. So it's the value, take away the start value, so in this case 19.27 minus 0, divided by the step value, and the step value is 10, so that's going to give me 1.927. And then I take the integer of that, which just rounds it down to the nearest, or rounds it down to the whole number. So index 1 equals 1, and then what I do here is I look at offsetting from this cell here, which is cell top left, so offset index 1, which is 1, and then I add 1 to that. So basically I'm taking this cell here, which is offset 1, 1 from this cell, and increase it by 1, i.e. I'm counting the fact that I've got one value in the range 10 to 20. So there, you can see that's increased to 1. Now the next value is 17.34, so I'm expecting the same thing to happen again. It'll increase to 2. That's good. Next value is 132, so this one should come up here in the range 130 to 140. Let's see what happens. So that appears to be working. Next one's 30.7, and so on. So it looks like it's working. So I will run it and see what happens. And as you can see, we've gone through all 14,000 pieces of data, and we've grouped them as so. So there's quite a long tail. I'm going to just drag this down a bit further. But we can see we've got a bit of a problem here, that a huge amount of data is at this low end that we've not got a very forensic detail about. So I'm going to make this step value smaller and do the same thing again. So I'll delete that. I'm going to make the step value 1, and let's run this again just to check it's working okay. So the first one's between 19 and 20, second one's between 17 and 18, and we run it again, and we've got an error. So we need to look into what we've got there, and the value is 66,000. What's happened there is we've tried to get a value off the top end of the spreadsheet. So I'm going to have to make my bit of Visual Basic a bit more sophisticated here, because although we've got a large number of pieces of data in the relatively low range, and you can see they start to dwindle when you get up to higher numbers, we've got some which are very, very large amounts indeed. That's not untypical for a general insurance distribution, a liability distribution, something like a motor insurance policy. So we need to make our Visual Basic a bit more sophisticated, and what I'm going to do is have a top value as well, so not just a start value of 0 and a step value, but a sort of highest value. And in this case, well, we can see here we've got a maximum of 117,000. That's the biggest value we've got altogether. But this time I'm going to make it, I don't want to have more than 1,000 individual data cells, so I'm going to make this highest value equal to the start value plus 1,000 times the step value, which is obviously going to be 1,000. Okay, so I'm going to call that value, or call it highest value. And I need to incorporate that in my Visual Basic. So I'm reading this value here, value equals cells a, 1, and if value is greater than highest value, notice we've got highest value in square brackets because it's taken from the name on the Excel spreadsheet, then value equals highest value. So what that's going to mean is that at the highest value of 1,000, it simply counts up the number of values which are over 1,000. That might seem a pretty cavalier thing to do, but if you think about, we might have an individual risk excess of loss reinsurance policy running, then that will simply reflect that sort of structure. And we might want to look at large claims separately from the overall loss distribution. And there's a simple practicality here that some of the large claims are way above what we can really handle with the spreadsheet. So I'm just going to put that piece of code in there, and then what that should mean is that now when I run this again, it won't go above that 1,000 value, and at the 1,000 value it will simply count up the number of claims that are above that 1,000. So let's just step through to make sure that appears to be working again. Okay, that appears to be working, so click the run button. And there we can see we've run through all the data. And you can see the instance dwindling, and there's 1,344 values which are above the top end of the distribution up to 1,000. So quite a lot. So we certainly can't ignore that part of the data if this is a genuine exercise. But for these purposes, I'm going to leave that element of the data and concentrate on the first 1,000 pieces of data, assuming that we would have reinsured that or dealt with that those eventualities in some other way. So this is now effectively a histogram. In fact, I can draw it as a histogram. I'll just look up to 100 just to show what this distribution actually looks like. That's probably the best chart to use there. And you can see very heavily skewed distribution, peaks early here and then tends down quite slowly. So we looked at some distributions on Thursday, and this is, we could almost, with it being so biased towards the low end, we could almost be looking at using, for example, an exponential or a Pareto distribution, which you'll remember don't actually have any, they peak right at 0, they don't have any sort of tending towards a peak and then going down again. But the other distributions we looked at could also be perfectly valid here with the right parameters.